Okay, Trigonometry Lesson 5, Determining the Angles and Sides in Right-Angled Triangles. This is on page 235. So class example number 1, I have drawn here. So we have a right-angled triangle. X is our unknown angle, and then they're giving us two sides. First thing we need to do is to label all of our sides. So this will be our hypotenuse, opposite, and adjacent. We have adjacent and opposite, so we are going to be using tangent. So tan x is opposite over adjacent, 12.7 divided by 5.2. We need to take the inverse of the tan, so x degrees is tan inverse 12.7 divided by 5.2. We get out our calculator, and x is 68 degrees. For 1b, we're trying to find side x. We still have to use the angle of 24 degrees to label our triangle. So opposite the 24 degrees is your opposite. Next to it is adjacent. Across from the 90 degrees is your hypotenuse. We have O and A, so we're going to use tangent. So tan of 24 degrees is opposite over adjacent. We need to solve for x, so times both sides by 68. So 68 times tangent of 24 degrees equals x. Now we use our calculator. We want the answer to the nearest whole number, so x equals 30. Please do 1c and 1d. Class example number 2. A telephone pole is 11 meters high and is supported by a wire 13 meters long fixed to the top of the pole and to the ground. Calculate to the nearest degree the angle between the wire and the ground. First thing you need to do is draw the diagram. So we have our telephone pole, our guy wire, and the ground. The pole is going to make a 90 degrees with the ground. We are told that the telephone pole is 11 meters and the wire is 13 meters. And we are asked to find the angle between the wire and the ground. We need to label our triangle. The wire is our hypotenuse. Opposite the angle is opposite. Next to the angle is adjacent. We have O and H, which is sine. So sine theta equals opposite over hypotenuse. We need to take the inverse of sine to solve for theta. So theta equals sine inverse of 11 over 13. Here's our calculator. Answer is supposed to be to the nearest degree, so it is 58 degrees. The second part of the question says that we want to find the distance between the point where the wire is fixed to the ground and the pole. So basically we want to find the ground, the length of the ground. There are two ways to do this. So one way you can use Pythagoras. So let's do Pythagoras first. Please remember that C is the hypotenuse, which is 13 squared. So we're going to have 11 squared plus, let's call the ground x, so x squared. So 11 squared plus x squared equals 13 squared. Subtract 121 from both sides. X squared equals 48. X equals the root of 48. And we want the answer to 0.1 meters. So we can use our calculator for this one. And you get 6.9 meters. We could also use trig. If we're going to be using trig, we want to find the adjacent. And we can choose. So we need to figure out which one here has adjacent. We could use either cosine or we can use tangent. Doesn't matter which, as long as we have the right equation. Let's just use cosine. Our angle is 58 degrees. Adjacent's x over 13. 13 times cos 58 equals x. And use your calculator, you get 6.9 meters. On page 236, question 3, it says solve the given triangle. I've drawn the triangle here. It's triangle ABC. Angle A is 37 degrees. Length AC is 33. And we're asked to give the exact answers to the nearest whole number. When it says solve triangle, that means you have to find all the sides and all the angles. So there's a couple ways to do this. We have 37 degrees. So if we want to use trig, we'll have to first figure out what side we want to do. First step is always to label your sides. That's going to be your hypotenuse. Opposite your angle is opposite. By it is adjacent. If you want to use trig, we have hypotenuse. So it's going to be easiest to use sine or cosine first to find your opposite or your adjacent first. Let's do sine. I'm going to call my opposite side x. And then I need to solve this for x, so 33 times sine 37 degrees. Nearest whole number, so that's 19.8, so that's going to be 20. And I label the sides, so then later on when I'm trying to figure out if I finished the question, I can see right away if I have. Now there are two ways to find your third side. You can use Pythagoras or you can use trigonometry. Both would work and both should give you the same answer. I'm going to use trig. I'm going to go cos 37 degrees. I'm going to label adjacent y. So it's y over hypotenuse times both sides by 33. And use my calculator. 26. We're left with one angle to find, angle C. And there are two ways to do it. We can use trig, and in fact we can use any of those trig identities now, or we can use the angle sum of a triangle. Angle sum of a triangle equals 180 degrees. That means all of the angles in the triangle must add up to 180. So we have 90 degrees plus 37 degrees plus C degrees equals 180. We solve it for C. So 90 plus 37, that is 127. Subtract 127 from both sides. So angle C is 53 degrees. And now we know all three sides and all three angles. Please do question number 4.